Today on Test Case TV, we are covering the use of single LEDs with a resistor based on voltage source. And we're going to go over how to choose the right resistor so that your circuit itself doesn't die, let alone the LEDs, and everything works. One of the things that we need to account for or to be aware of when choosing resistors for a circuit is this thing called Ohm's law. And it's going to be repeated through many of our choices as we dive deeper and deeper down this rabbit hole. Ohm's law states that V, which is volts, equals IR. I is our current, and that is in amps. R is the resistance, or the resistor value, all right? And that one is in ohms, which we learned all about with the multimeter video. In the world of diodes, we have to consider something called forward voltage. And what that really means to us when we're planning out our circuit is that there's a certain threshold of power or voltage that needs to be reached before it will allow any power or electricity to go through the device. All right. So for example, my red LEDs here on site have a forward voltage of 1.7 volts, whereas my blue LEDs have a forward voltage of 2, and my green have a forward voltage of 2.2. So each one of those I can have in the same 5-volt circuit, but since they have different forward voltages, I will choose a different resistor value for them to have the same intensity or the same current going through those LEDs. So when dealing specifically with LEDs, when we look at Ohm's law of V equals IR, which we now basically understand, and the forward voltage of the LED, we need to account for this in this simple equation that's going to be repeated through everything we do. For example, our 5-volt system minus the forward voltage of a red LED, so 1.7, so 5 minus 1.7 gives us a voltage of 3.3. That's what we have to resist on, not the 5 volts in total, because it's not actually going through the circuit. So now we have a 3.3 volt system equals our current that we want for our LEDs, and then the resistor that we need to choose. Most LEDs have a max rating of about 20 milliamps, all right? So in our equation, it's going to be 0.02 amps, all right? So now we have 3.3 equals 0.02 times R. Now the only way we can find R in this case is actually take 3.3 divided by 0.02, and that's going to give our resistor value for that circuit. So 3.3 volts divided by 0.02 amps will give us a 165 ohm resistor. So a lot of times you won't find the exact resistor you want in a kit, like a 165, but you can find something close. And for most of our circuits, close works fine. You'll find a lot of these beginning things aren't that intensive. So it's kind of non-issue. You can get a 160, you can get a 170, you can do 150 and it's going to allow a little more current. You can go 175 and it'll be throttled a little less. Whatever. As long as you're in the range, you're protecting your LED from killing itself and the circuit. So with that being said, let's plan the circuit out for, say, our blue LED. Blue LEDs have the forward voltage drop of 2.0 instead of the 1.7. So now our circuit that we need to plan for, instead of 3.3 volts, is now just 3 volts. 3 volts with a target current of 20 milliamps, because that's what we're shooting for, is going to get us to a 150 ohm resistor. So it's slightly different than what we chose for red, but it's still something to consider. And helping us to get in the habit of planning for that helps us to plan for many other circuits down the way. And it's the same for the green as well. So the green was the 2.2 forward voltage. So it gives us 2.8 that we're working off of instead of 3.3 with the red or 3 for the blue. 2.8 with 20 milliamps will get us to the 140 ohm resistor. So that's our range right now. We have 140, 150, and 165 between red, blue, and green. So let's jump down the rabbit hole for a second and plan out a circuit. Let's go for something that we might have a little more readily available, like a 9-volt battery, right? We can get those at a store, so let's plan for that. If I put my same circuit with those resistors on a 9-volt battery, it's going to allow more current, and that's going to have the LED essentially burn itself out. So it's not ideal by any means. Not for longevity, not for safely installing in anything. Because an LED burning out, it's still burning out. Like literally, it's catching fire inside the acrylic until it no longer conducts electricity.
Oh.
So with a 9-volt, let's start with the red. All right, 9-volt source. That's what we've changed to. Still the same voltage drop of 1.7 for the red LED, and the same target current of 20 milliamps. All right, that equation, just like what we were looking at a minute ago, gives us a 365 ohm resistor. So let's switch from our red to now our blue, which has a forward voltage of 2 volts instead of the 1.7. But this time we're still using the 9-volt battery, and let's find out the resistor value for that. So 20 milliamps is still our target goal because we don't want our blue LED to burn out, but we're at a higher voltage. So now we need to change it up so that the 7 volts for the blue is now divided by 0.02. That'll give us our 350 ohm resistor value. And that will basically do the same thing as what we did for the 5-volt source, only with the 150, all right? And the same thing goes, of course, for green with the 2.2 voltage drop. The resistor value for that one will be 340 ohms. So all of that means that we can now select resistors based on our voltage source minus the forward voltage, and everything's going to be happy. So I hope that helps. Let me know if you have any questions down below, and that'll be it for today.